I've stated that we need to program in a state programming style. The question is, why? Why do we want to do this?
Well, first of all, with state-based type programming, we can have multiple applications running. So if you think about your microcontroller code, it usually has one application that runs. When we do state-based programming, we can have multiple applications that run all at the same time, sort of like multitasking. State-based programming also breaks the programming into chunks. It's always easier to program your applications when you break down the complexity by making everything you have to do in smaller parts. You can test them in smaller parts, you write them in smaller parts. It's just a lot simpler. And finally, we don't have an RTOS, so a real-time operating system. What we get with state-based programming is a quicker response for each application and a little more predictable. Now let's take a look at what they look like. Graphically, our state diagrams look like this. We have a state here, and this state tells us something about the operation of our application, what it's supposed to be doing. The state also has an arrow coming out of it that says, I will leave this state and go to a different state of operation if these transition events occur. And it could be one event, it could be many events, it could be no event. If it's no event, it means you're in here, you take whatever action this state needs to take, and you immediately go to the next one. So this is our state diagram sort of setup. This is how they're made. Now if we add in a little bit to this, we can see the rest of a state diagram here. Typically they will follow a pattern around in a circle. They don't have to go always back to the first one. We could have a dynamic change from any of these states, say state 3 over to state 1, based on a set of events. So that from S3, if these events occur, we go to S0. If these events occur, we go to S1. If no event occurs, it's implied that S3 will just cycle back around to itself. And in terms of convention, oftentimes we say, starting right here, this is the first event to check. So if these events happen, that's where you go. Right? But if they don't happen, then we got to go and check these ones. And finally, this assumed one, we don't usually draw it in, is the last one to check, where you stay in that state until some of these events happen. Oftentimes, because the actions that are taken in the states are too big to fit on the diagram, we can just put a label for the state and maybe a descriptive label below it. So S0 is the state. This label here would maybe be idle or initial state or whatever it is. And then we can put in our actions here. And it may be do nothing. And then when we get to S1, it could be another action. Right? So we can have a state and action table. And in fact, we often have state, action, and events are the next part of the table. I've only shown state and actions here, and I've put all my transition events on the diagram. Sometimes the transition events are too much, and you put them into the table. Hopefully, for what we're doing, we don't have to do that. We probably will have to make this table, though.